Today we are going to be looking at JAMB Physics examination for the year 2024, question 1 and 2. And the first question says, the stress experienced by a wire of diameter y/pi loaded by a weight y square is, this one's, the meter is the unit of diameter, and the Newton here is the unit of the weight. I take the question again. The stress experienced by a wire of diameter y/pi loaded by a weight y square is, these are the options: A, pi newtons per meter square; B, 2 pi newtons per meter square; C, 4 pi newtons per meter square; D, 8 pi newtons per meter square. So let's take the solution. Stress equals to force all over area. So we are to find the stress, and of course, if you look at the equation, the force is given as y square. So the weight is the same thing as force. We have it as y square. And we are to also find the area, but in the equation we have diameter as y/pi. So what we are going to do is to pick an expression for the area. In this case, I prefer using pi d square over 4, but even if you use pi r squared and then divide the diameter into 2, you will still arrive at the correct answer. And if you like me to solve it using pi r squared, you can as well comment on the comment section. Okay, so here we have area equals to pi d square over 4. So we are going to substitute equation 3, which is the value for the diameter, into equation 4, and then we simplify. When we do that, we arrive at this point. This is the initial expression. Substituting the value of d, which is y/pi, we now get the next expression. So don't be confused about that. Okay, the next step. We now expand the equation, and if possible, we cancel out. For us to expand this equation means we are going to multiply the index here with the numerator and then the denominator. So when we do this, we have y squared and then pi squared. Okay, so when that is done, we will arrive at pi y squared over pi squared. Of course, you see we have double pi below and one single pi on top. So this will cancel one of these, and we would be left with y squared over pi. Which is the next step. And looking at this mathematically, I might decide to put over 1 below here. Why I'm doing that is that anytime you are solving any problem of mathematics and you get to this point, you need to do this to help you simplify it to the next step. So assuming I have something like a all over b divided by c all over d. This is the same thing as a all over b times, you now invert the denominator. Invert the denominator, that would be d over c. When you invert the denominator, it changes the division sign from division to multiplication. by doing this, you will be able to go ahead and simplify it. Okay, so now put y squared over pi all over 4 over 1. I invert the denominator, the fraction below, and this is the next value I will get. So with this, I've been able to get the area. So my quantities are completed. So I now go down to equation 1. In place of the force, I am going to substitute y squared, and in place of the area, I'm going to substitute y squared over pi over 4 pi. Yes. Now, we are still going to apply the same principles. Here we have, assuming we have A all over B divided by C. Mathematically, this could be simplified, and we will get A times C over B. That's what we are going to do basically. When we do that, we will get this. And looking at it, you see that y squared is common, and all we have to do is to strike this. Anything divided by 1 is still that same thing. So dividing this by 1, we are still going to get 4 pi newtons per meter square. So the option here was pi newtons per meter square, 2 pi newtons per meter square, 4 pi newtons per meter square, and 8 pi newtons per meter square. So the correct option is option C, 4 pi newtons per meter square. Let's take the next question. Under which condition is work done? Under which condition is work done? Okay, so the first condition is given here. The first condition is given here, and it says, a man supports a heavy load on his hands. A woman holds a pot of water. A boy climbs on a table. A man pushes against a stationary petrol tanker. For work to be done, there must be a product of force and displacement. So all we are going to look out for is whether there is an application of force and whether there is any form of displacement. So if we don't have any, then it is assumed that no work was done. A man supports a heavy load on his hands. He just supported the load. So was there any change in displacement? No. So there is no work done. It doesn't matter how long the man was there. What matters is there any change in displacement? Is there any application of force? If there is an application of force, was there any displacement? Okay, so that's what we are looking out for. So the first option A does not hold. B says a woman holds a pot of water. A woman holds a pot of water. Okay, was there any displacement? No. So there is no work done. A boy climbs on to a table. A boy climbing on a table, he has applied an amount of force, fine. And there is a change in displacement because he has ascended from where he was to the table. A boy climbs on to a table. Okay, so there is a level of force applied and a change in displacement as well. Let's look at the last option. A man pushes against a stationary petrol tanker. He is pushing, but the tanker is not moving. And as such, that's not the correct answer. So the correct option is C. A boy climbs onto a table. That's how far we can go for today's lecture. Thank you for watching Supreme Online Lectures. If you like to support our channel, please check the description below for more details. Thank you. If you have not yet subscribed to this channel, please endeavor to do so. If you have subscribed, Thank you very much. And if you are yet to like and share, please do that. Have a wonderful day.